So very good morning, everyone. So today we are going to let you know about terminologies which are being used in stereochemistry. In our previous video, we have seen that stereochemistry is a branch of science which deals with the three-dimensional structure of the compound. And we can represent the three-dimensional structure on two dimension on a paper by some formulas. And for a stereochemistry, the carbon should be sp3 hybridized that we have already been discussed in our previous lecture. But we have used some terms like enantiomers, chirality, optical activity, and many more. So in this particular video, we will talk about the terminologies which are being used in stereochemistry. So let's start with that. So first term that we are using is optical activity. So before starting the optical activity, I will explain what is plane polarized light. So the light which is coming from the sun or any source, suppose, it is dispersed in every direction. The ordinary lights, because they composed of different wavelength of light which are vibrating in all the directions. Okay, so now the question is how to make it a plane polarized light. So we have to use the polarizers. Which polarizer we are going to use? It is a Nicol prism. So when we pass this dispersed light from the Nicol prism, then we will get a single plane, light which the whole light is vibrating only on a single plane. So such light whose vibration occur only in one plane is called plane polarized light. So after this, there's a sample tube when you are passing this light from the sample. Now sample is your compound. So the compound has ability to rotate the plane polarized light towards right direction or the left direction. If it is rotating in the right direction clockwise, then we will call it as a dextro-rotatory compound. But if it is rotating in the anti-clockwise, then we will call it as a levorotatory compound. So next, I will show you that how dextro and levorotatory we can represent. So dextro is a Latin word dexter, that is right. So which is denoted by plus and small d. But in a levorotatory, when your compound rotates a plane polarized light to the left, means anti-clockwise, then it is called levorotatory. So the Latin word leves means left. So it is denoted by negative or small l. So how much change has been occurred? That the light which you are passing through the sample and the sample is rotating the light. So the compound which rotate the plane polarized light, we call them optically active compound. And the property, this is called optical activity. So rotation of the plane polarized light that I have already told you, this can be a dextrorotatory, it can be a levorotatory. Fine. So now what angle has been changed? Change in the angle of the plane of the polarization is called optical rotation. That can be, measured by the instrument that is called polarimeter. And by this formula, we can find out the specific rotation, that is alpha, that this in the concentration bracket is called specific rotation. It is a specific rotation. Here T is the temperature, this lambda is the wavelength of the light, this alpha is the observed angle, and this is length, and this is the concentration of the sample in gram per ml of the solution. So this is how we can, say what is optical active compound, what is optical activity, what is plane polarized light. So these terms are being used in your stereochemistry. So that is very important. So next term I will talk about, that is the chirality. Basically, chirality is when the carbon is attached to 4 different groups. This carbon is called as chiral carbon. But in terms of chirality, when we are taking the Greek word char means hand. So it is a rule of handness. So I'll let you know. If suppose it is your hand and this is the mirror image of the sun. If the mirror image, when you are supposed to put it on it, so it's not going to be superimposed. So one thumb is here. So when The compounds, they don't have superimposable mirror images. Those compounds are chiral in nature. Okay, so if you will see here, so when you are going to put this hand over this, so this thumb and this thumb, they will be like this. So they don't have superimposable mirror images, so they are chiral compounds. But what is achiral? Achiral is just different from, means opposite to it. So they will have superimposable mirror images. So how we will get it? So take a one example of this butterfly. So there is a one plane. So this is a hypothetical plane. It will cut the compound in two different same half. Like if can you cut this hand in the same way? No, there will be three fingers, there will be two fingers. It doesn't will it will do not cut the compound in the two same half. But here the butterfly, there is a symmetrical plane which cut the first and second part in the same, and they have having the same images. When you will put it here on this, then you will get it very nice. They are properly superimposable. So these compounds which have internal plane of symmetry, they are called achiral. So these planes are not, they are just imaginary. You can see these are some hypothetical planes. Means it is in our mind, but we are not saying that there is a one plane. Okay, so the another term that you should know, that what is symmetric center and the chiral center. So they are the terms which are used to designate a carbon which is tetrahedrally bonded to four different substituents like 1, 2, 3, and 4. So when the carbon which is attached to four different groups, that is called chiral center, and that whole molecule is called chiral molecule. We can say like it is a symmetric atom, it is a chiral center, or it's a stereo center. So now we will take some example with help of which we can check that which is a chiral compound and which is not a chiral compound. And we can also find chiral centers with few examples. So let's take one example here. In this carbon is chiral. Why? Because it is attached to four different groups. So it is chiral carbon. In the second example, so here this carbon is not attached to four different groups because these two groups are same. So it is not chiral. In this, it is attached to four different groups. Yes, it is chiral. Here, this carbon is not attached to four groups. It is only attached to three groups. So it is not chiral. Very interesting part of this, that this example, the fifth example here, you can see two chiral centers. So here, this carbon is having four different groups. This carbon is also having four different groups. So there are two chiral centers. Okay, so main point is that chiral center always represented by asterisk. Okay, here you can see three asterisk are there, means three chiral centers are there in this example. Now, very important term. Next term is, what is stereogenic center or stereo center? Stereogenic center is defined as an atom on which interchange of any two atom or groups. So this is an simple atom, and these are two groups. If you are going to interchange them like this, when you are going to interchange, so there is a new stereoisomer will form. Stereoisomers having the same molecular formula but different structure. So when new stereoisomer is an enantiomer, you can check. Can you put it this over this? Will they superimpose? No. If they will not superimpose, then we will call them enantiomers. So the stereo center is called now chiral center because it is attached to four different groups. So we will say the first and the second, they don't, they have non-superimposable mirror images. So that's why this stereo center is a chiral center, but it is not in the example. Here, this carbon does not attach to four different groups. And similarly with this, whether you can interchange them, they are not enantiomer first and they are diastereomers. So in this case, stereo centers are not chiral centers. Stereo center are those when two groups are interchanged, you will get different stereoisomers. But they are not chiral, they are not enantiomers because they are not tetrahedral. So this tetrahedral means the carbon is not sp3 hybridized. So we can conclude this that all chiral centers are stereocenters, but all stereocenters are not chiral centers. And if a molecule contains only one chiral center, it must be chiral. A molecule containing two or more chiral centers may or may not be chiral. So I'll take one example, the tartaric acid, in which there is a hypothetical plane which can cut this compound in two halves. So it is achiral. So there is no, there can be a stereogenic center. You can interchange it, but they are not. So achiral due to the presence of plane of symmetry. And I hope you have understood what is optical activity, what is chirality, what is optical active compound, dextrorotatory, levorotatory, chiral center, stereo center, and asterisk to donate the chiral center and chiral carbon and sp3 hybridization and diastereomers and enantiomers. So I hope you have got this video lecture to understand the concept of stereochemistry and some terms which are being used in the your stereochemistry. Thank you. So in next term, we will talk about the another term like this. Okay. So plane of symmetry in which there is a plane that we have already talked about. It is a hypothetical plane which can, cut the compound in the two halves. Here there's a plane of symmetry AA. And here is also plane symmetry AA, DD. Same. When you will cut, this is one compound, you get A here, D here, D here, B here, B here. So this is a plane. But if you will cut like this, so plane of symmetry, plane of symmetry, plane of symmetry. So plane of symmetry is very commonly found in achiral compounds. Achiral means which don't have, which are not chiral, which don't have tetrahedral compound. So basically plane of symmetry is an imaginary plane which passes through the center of the molecule and divides the molecule into two equal mirror images parts. Now there is no plane of symmetry. Can you cut it? No, different. Can you cut it like this? Different. So you don't have plane of symmetry. When you will cut it like this, no plane of symmetry. No plane of symmetry. There is no plane of symmetry. So these are the compounds of the example which they don't have plane of symmetry. They're achiral compound. And similarly, there is another term is being used is proper axis or simple axis of symmetry. That was a plane, but here it is an axis, just a one. So here it is an imaginary line, basically. It's not a plane, it is a line which passes through the center of the molecule and one complete rotation of the molecule by 360 show identical structure more than one time. When you rotate, you will get the same hydrogen, hydrogen, chlorine, chlorine. So everything is same. So they are saying the 1 and 2 dichloroethane has simple axis of symmetry that passes through the midpoint. It's a midpoint. Okay, so after the rotation, you will get the same by 360. So similarly, methyl chloride, if you will rotate by 120, then you will get, then 120, then you will get. So similarly, in benzene, there can be simple axis. In a water, same. This is called symmetry of axis, and after the rotation, you will get the same symmetry. Okay. Another is improper axis of symmetry or alternating or improper axis. So basically it is also imaginary line which pass through the center of the molecule and on the rotation about by any angle. So but it particular angle followed by the reflection perpendicular to the axis of rotation shows identical structure more than one time in one compound by 360 degree. So here it is a or improper. It's not like this, it is like this. So like this. And then you will see the perpendicular, then you will get to have this. So this is not that much being used in your syllabus, but it's fine. You should know this. Center of symmetry, there is also a line which equidistance from the diagonally opposite identical atoms of the group. So it can be used as it is an imaginary point. Okay, like this. So here it's imaginary point. So hydrogen is having same difference. It's also having same. So they are having center of symmetry. There is no center of symmetry, right? Because this hydrogen and this chlorine, they don't have the same. One is back and one is another front. This is how we can talk about the symmetry. So another term is being used in the stereoisomers. This is called enantiomer. So basically, what are stereoisomers? So isomers having same molecular formula but different spatial arrangement of the atom are called known as stereoisomers. They can be enantiomer. So enantiomer we have already talked about that the first compound should be chiral. Chirality is the necessity and sufficient condition so that an enantiomer can exist. Second, they have non-superimposable mirror images. Okay, so any two and one compound with its mirror images, if they are having non-superimposable mirror images, they are called enantiomers. But diastereomers, they are not or mirror images of each other. So if you will see different, they are enantiomer. Because when you are going to put it here, so they are not matching their superimposed. Similarly, they are enantiomers. But if I talk about AB and C, both they are diastereomers. Okay, they will be same. Okay. So another term is being used is geometrical isomers. So in geometrical isomers, in which there is a restriction of the rotation of the about the carbon-carbon double bond, basically. Double bond cannot rotate. So this is called cis-trans isomerism. So in cis, what will happen? Compound of the same kind will be on the same side, and in the trans, they are on the opposite side. You can check it like this. Okay, so isomers, they can be exhibit the compounds like having carbon-carbon double bond, carbon, nitrogen, and nitrogen in or in the cyclic compounds. You can check this double bond restricted rotation due to the steric hindrance. So these all are geometrical isomers. And moreover, another term is being used is conformational isomers, in which what will happen, you can convert, I can say that conformation, they are isomers that can be converted into one another by just rotation, by the single bond. First of eclipsed, anti, goche, like this. So in eclipse, you will get very less difference, 0 degree difference. In this, there's I think 60 degree. In sorry, in and you can say in anti, all the in goche there is a 60 degree rotation. Okay, and another, if you will talk about the anti, they are just opposite, like 1 degree, 180 degree. These molecules by you have to just this carbon, this is also one carbon, this is also one carbon. So they are like the cyclic compound is like this. Okay. So what we have learned, asymmetric carbon, diastereomers, enantiomers, and mesocompounds and optically active molecules. So we have seen this. Uh, I hope you all have, understood this. DL system we have already done with that, the dextrorotatory and levorotatory. So thank you guys.